Hello everyone, my name is Anton and I'm a software developer with a background mostly in backend development and telecommunications. I used to develop really a lot in C++, and there debugging any memory issues is actually quite a common thing, right? In such languages you have to deallocate memory by hand. There are numerous other issues like your code can start modifying or reading memory out of allocated boundaries. That's too bad always. Or there are there can a lot of concurrent modifications happening to your memory because it's quite often shared between threads of execution. So then I was introduced to Erlang. I found out that the language and the platform in general is liberated from such trivial or classic memory issues. Um, it's a garbage collected language, so you don't really have to think much about freeing the memory. Um, Data and memory is uh, is owned by the process separately, by different processes separately. So you don't usually have a chance to modify it concurrently from a different processes. And even like the structures, right, like lists or whatever, they have such a high level API, so you cannot really go out of boundaries of their allocated memory. So this is all great. This helps you avoid a lot of so-called like classic memory issues, but there are still others, other issues that you can encounter, and usually they are more complex because they're also like much more high level. So I had this talk at elixirconf.eu this year, and there I talked about some of behaviors and pitfalls that you can generally encounter in the Beam ecosystem. Um, I went through the things like a loss of sharing, or we've seen some examples of when Elixir programs can actually leak memory, or even more interesting, then they don't leak memory, but they retain it for so long that it actually might look like a leak, um, yeah, like a memory leak. From my presentation, though, there was a one thing that I didn't have time to do. I didn't have time to show any tooling and how to use it. So it was more like theoretical walkthrough. And so I'm glad that I have time and opportunity to do it now. All right. So I'm going to start with example that I also had during my presentation back then. I won't dive deep too much because here we won't be looking for an actual reason of the problems. We just want to pinpoint exact place of it and see like what is a culprit. So right, you have a database and you have an application that works with some like recipes and cooking. So I have quite a lot of recipes, you see like around 1,000 or so. And each recipe has several ingredients that you need to cook it, and each ingredient points to one product. So the product would be like something you can buy, like apples or pasta. The recipe ingredient would be like 2 apples or 300 grams of pasta. Um, it's very easy to describe that relation through actor schemes. So you see like the recipe has multiple ingredients, and each ingredient has one product to which it points to. So as an example, I made a very simple endpoint that just queries all the recipes. Supposedly you need it for some feature, like in my work and choose you, that is the case. Um, and we want to preload all the ingredients for recipe, and for each ingredient we want to preload the related product. So you deploy your application or you debug it for some reason locally. You see that the footprint of your new function is not that big. You can definitely live with that. But then you're getting supposedly very unsatisfied with how many database requests and how many database traffic is going on. So you want to try to cache all the recipes that you get. And suppose if you deploy a new version and your nodes just start to crash, they start failing with out of memory errors. For simplicity, suppose you let's suppose you deploy your application as the Docker. You distribute it as a Docker images and run it as a Docker containers, and those containers are the one who failing with the out of memory. So the question that I want to ask, like, what is the first step you're gonna do? I will return to the chat. Sorry for the for like the infinite view. You can type some like suggestions to the chat. Memory profiling. Well, how do you profile your memory if your application failing like few minutes after it starts? Like you cannot connect to it. I guess you can grab an image and debug it. But it seems to be, yeah, I'm talking about crash dump. I would say it's an overkill. The thing that I would suggest here is very simple. Just give it more memory, right? If your application used to work before it started crashing without of memory, just please give it more memory. Especially if you're using some cloud provider, it's very easy to do. I don't know, like in my experience, 95% times it's gonna temporarily solve your issue. And then you get the opportunity to find a real culprit and, well, debug it, because you won't be pressured by your team lead or boss or whatever. Your application will work. So for instance, how would you do that? I'm running my application locally, and I'm just going to connect with it to it within IX. If you're running your application remotely, you're probably going to SSH to the node first, and then also run IX shell with connection. So because I'm running my application locally, I'm going to start with a very cool tool that I use a lot, but only then I run my apps locally. There's a reason for that. It's called Observer. It's gonna start somewhere. Let me just pull it to the workspace where it will be like easier for us to see. Right, so here you already can see some parameters, but they're global. We wanna go like deeper and find like more details about what's going on. So here is like a graph of our memory. You can see that the heaps that are occupied by the process are this light blue. You can see that ETS is pink. Almost no space is occupied by ETS tables now. Red is total. I'm going to pop up my Postman and try making requests to my app. So I already see like some spike, but it's actually not big. The app was just deployed, so the first like request taken more memory. You actually see like heap allocations pretty small, but something going on ETS. Like some memory is now occupied in ETS. So why not shoot another request? Well, you see it's kind of now starts to get a little bit worse, like a more memory is occupied on heap. The memory on TS remains. So that already can give you some suggestions of what's going on, like the things that you store in ETS, for instance, are more long-term. So maybe it somehow relate to your caching. The heap is something that processes usually use a lot. So let's go and see what's going on with the processes. I will try to order them by the memory consumed, and it will need some time to refresh. Yeah, I see that a lot of memory is being consumed by the bandit delegation handler. if you worked with Bandit Phoenix before, you know, like this is your handler. Yeah, your like controller handler. So then you can like already maybe start and look into something deeper. But you remember that we also seen something is being allocated in the ETS. So you can do the same thing for ETS. You can check out your ETS tables. And here it actually gets more interesting because you can see that this is an EnableX backend that uses ETS. So the ETS table that occupies around like 55 megabytes is actually related to NebelX. NebelX is that caching library that is used here. Yeah, so I guess that would be kind of enough of the tip for you to start to go into. And the reason for that, for the actual issue, was like so-called loss of sharing. And once again, I told we won't be looking too much of what exactly the memory issues are. We're just more interested in just finding the place where they happen, and then assume that after you find the place, you can pretty easily like figure out what's going on. But the loss of sharing is an interesting thing. Then you move a lot of data structures between processes in the beam, so Erlang, Elixir, or whatever, or you move them between processes, or you move them between ETS, like two ETS or read from ETS. Then the size they occupy can grow because of that so-called like loss of sharing. But what if you can't really run an observer? The problem with it that you need to install the observer graphical user interface application to your machine. And also it's not that easy to connect it to your remote node from your machine because you need to do like a port forwarding. For instance, in AWS, so we run Docker containers in AWS. It's so uneasy that most of the time, what I'm and another developers are gonna do is I'm gonna use the observer CLI. That's kind of the alternative that works just like in the command line interface. So you can see there are also a lot of global stats here, and you also have a list of processes that now like ordered by memory. I can select other options, like I can order it by message queue. It also needs some time to do like all the ordering and querying for the processes. Yeah, so you can order them by message queue. I'm going to return back to ordering them by memory, and I'm going to run my request again. Don't need observer anymore. And I'm going to go back and see. Yeah, we can see like the delegating handler is here. And if I type the number of the process here, I can look deeper in what's going on. Here it's not much interesting things because it's temporary process. So let's return back to home. Yeah, but you know that this is like basically your handler in your controller, as well as you could do it. You could do it with observer before, and you can also check the ETS tables. By default, they're also ordered by the memory they occupy, and you can see as well here that you know the culprit table is a NebelX backend. So I guess this is all I wanted to show with Observer CLI. Yeah, it's really cool that it's just a dependency to your application. Of course, you need to also to install it to include this dependency to your like production deploys, but it's pretty safe to use and not that big. But what if for some reason you cannot use or don't want to use the Observer CLI? Or for instance, you don't want to really monitor what's going on, but you want to debug some long-going problems, like memory leaks, for instance. Elixir code can as well leak memory. So what would you do in that case? My recommendation is the library called Recon. It's more like a selection, a tools, like a toolbox with different tools and functions that help you do debugging in the Elixir or Erlang systems. And you also just need to include it as a dependency. That is cool. And it really has a lot of stuff in it. And actually, Observer CLI uses it heavily to output, all that information that you have already seen. So you're gonna see that's like you can actually debug pretty much all the same things. You have pretty much all the same tooling with the Recon itself. So the module that Recon has for specific that it specifically dedicates to debugging memory is called recon_alloc. So the function memory gives you information about like global memory allocations. I think it's called like allocated. Yeah, you can see how many memories allocated by your virtual, like Beam virtual machine. You can see how much is used. There is an allocated types that return you allocations made by specific allocator, and it's actually pretty easy to understand because binary alloc means how many like binary or strings occupy the memory. Heap is the process heap, ETS is ETS, and standard basically everything else that is not super specific falls into the standard allocator. The one cool thing here is you can also query the max, the historical maximum of memory allocated by the allocator. That can be useful. Like in our case, I just started the node. I have seen something going wrong with the memory. So maybe I was not able to track the memory consumption during the issue. So I want to know like the values, the maximum values of memory that was allocating during like the issue. So that's help. All right. I think that's it here, like with the global parts of Recon. So then Recon has a very useful function called proc count. So that already allows you to list processes according to some attribute. Like for instance, I'm going to use a memory attribute. Recon define private. Did you mean? Oh, what did I do wrong with it? Right, yeah. Doesn't have like a default parameter on the number. Yeah, you need to specify the number of the processes that you want to see. And it's going to order them like in the descending order. So let's try to reproduce our behavior again. So I run the request. I'm going to call like proc count. Well, it's not, you can guess that this is like the same handler process that we've already seen before, but it's not so descriptive. But the cool thing that it returns you Elixir structure. So right now you have the most powerful tool you can have as an Elixir developer, that is Elixir itself. Right, so I'm just gonna modify my call a little bit to capture the problematic process ID. And once again, I have to trigger an issue just in case. Right, I think I have captured something, and then I can use Erlang, like a platform function that's called like get status to get information about a specific process. And so here I have like some process state and its status. I see it's a change error that's somehow related to the endpoint. and that initial call is banded delegation handler. So that's going to be like enough for me to kind of also probably pinpoint an issue. So what's about the proc count? It's more flexible because you can use a different attribute that it knows. For instance, if I want to ask the process, if I want to order the processes by the specifically binary memory, like a memory that occupies with its strings, I can do that. Another thing is also very important. It's message queue length. So it's basically how much messages the process currently have in its message queue. It's a very good thing to look into anyway if you have some problems on your node. But there is like at least one reason why you want to look into it, then you debug in memory. But I'm going to return to it in a bit, because there is like another function that is undocumented in the ETS model. It's called ets.i, that returns you the information about all ETS tables. It's pretty ugly and hard to read, and the function is not documented, but it's nice for debugging purposes. So I would recommend to call it as well if you don't have any other tool to like debug your ETS tables. So I can already see that there is a lot of memory occupied once again by the NebulaX ETS backend, our like caching backend. Right, so let's return to the message queue thing. Sometimes there are things that look like leaks, like you can see on the graph that your memory is growing up and it's not being returned. So they look like a leak, but after some time the memory is actually returned. So this problem is that sometimes like a garbage collector can actually retain some memory even if it's ready to be freed. Um, and these issues I think are a little bit harder to profile. So let me also show you another slide. Um, so there are like few reasons why the garbage collector can behave like that and not collect the memory that's ready to be reclaimed. And if you're debugging such an issue and you found a process that you think might be leaking or retain or keeping the memory, having like a long memory retention, the first thing you might want to try is to run erlang.garbage collect on this process. That generally should be safe enough to run even on production nodes, because the garbage collection runs by the process, by a singular process in Erlang and Elixir. So that should not be too much of the issue. So what I'm going to do, I'm going to capture the culprit process again. So I'm going to run my request. I see I captured the process that I need. And so it's like Erlang garbage collect, and I give it a pit. It returns true, it was successful. And then I want to ask how many memory now process occupies, because we already seen it occupied quite a lot. Well, relatively a lot. And I'm gonna ask for memory. Yeah, you see like a memory that process occupied after garbage collector actually been called now fall down very a lot. Once again, here it's not that much of an issue because this process is a very short-lived. It's just for handling the request. What you can also do with it, yeah, I think this process already have died, so I'm gonna run another request. I'm gonna capture another process, and I'm gonna that time ask for the message qlen. Here it's 0. Once again, the application is basically idle, doesn't do anything. But why you want to check that, as that one of the reasons why memory could be retained is then processes accumulate a lot of messages in their queue. And so the way how garbage collector works, it has two heaps, the young and the old. And when it sees that objects or the data, the structures, they have been, they have survived few garbage collectors, it moves them to the old heap. From there, it's hard to, they're like harder to be reclaimed. So basically, like in future, garbage collector will have a harder time reclaiming the memory that it moved to the old heap before. And if your process accumulates a lot of messages in its message queue, most likely that's what's going to happen to them. Garbage collector will run. He will see that these messages just stuck around. They are not being removed and going to move them to the old heap. Another thing that I wanted to talk about. So far, I used two calls that are part of Erlang and, well, as well, Elixir platform. That is a sys.get status and erlang.processinfo. But if you look online, there are a lot of people who will advertise you to be more careful with these calls, because they can, if you don't, if you're not going to specify what exact information you want to be returned, they can return you such things as the messages in the queue or the process dictionary. And if there is a lot of information, you're just gonna end up loading your system more than necessary, and that's actually can have like a negative effect on performance of your application. So simply saying, then you debug, you don't really want to make things worse. But there is a good news, because Recon has a function that is safer and it's actually easier to remember. It's called Recon info. And okay, the process have died, so I'm gonna reproduce an issue again. I'm gonna capture the bit and I'm gonna call the info. So it tries to avoid querying any information that can be like heavy for your system to process. And here you can see as well that it's banded delegation handler. It's even cooler because you can see sometimes like a stack trace. And as well, you can call recon info with some specific information like memory or whatever, like message queue len. Yeah, so it's just like a better function to use, generally safer. All right, what also I have left? Another reason, there are like a few reasons why your memory can be retained and would not be reclaimed as quickly. That, like the message queues, the big message queues is one of them. Another of them is if your process uses a lot of large binaries or strings. I mean, if you're working with HTTP or with textual messaging, most likely that's the case. The process is gonna be working with the binaries a lot. And what happens that big binaries actually allocated on a separate heap that's called a binary heap. And the processes just have a reference to it. So they don't really keep all the data in their own heap, but they reference it. And because these references are pretty small, even having a lot of them might not be that heavy to trigger a garbage collection on that process. So that can lead to these references being around for a while, and the memory that these binaries occupying would not be reclaimed. For this specific thing, Recon has a function. I'm just going to run my faulty request again. And the function is called bin leak, I think. And you need to give a timeout. So what it's going to do, it's gonna go through all the processes in your system. It's gonna count how many references to the binaries they have. So it won't count a memory that is binaries occupy, just a number of references. Then it's gonna run manual garbage collection on each of your processes, and then it's gonna count again. And one of the values that is returned is this number that tells basically how many uh, binary references being released. The values here, believe me, are not big. But if you think like 1,000, 10,000, that's very likely is an issue. Some processes, for some reason, retain the references to the binaries that are not being collected, and that occupies a lot of memory. As you already probably understood yourself, this function, the calling this function is more risky, right? It's doing a lot of work. It's triggering a lot of garbage collection on processes. So that's why it has like a timeout. Um, but yeah, in general, I think while it's very useful, you should be more careful than you want to run it. And that's like the main things I think that I wanted to show. Do we have any more time? Well, I assume we do.
We still have some time, so don't worry.
Yeah, okay. Yeah. So that's not so much about debugging, but I think you do want to monitor your memory, and probably you also want to monitor like not the whole memory, but like a specific allocations, how many memory does the total like heaps use that are used by the process, how much memory ETS tables take, and so on. And if you don't have that, you might want to use telemetry with a telemetry poller. I mean, reality these days is that your application most likely going to use telemetry anyway already. If you use Phoenix, if you use Ecto, they use telemetry. So you might also, in that case, start using it. And what poller does, it polls periodically certain functions, to get a value. So from the values that it can poll by default is like a list of, let me see, where is it, like measurements, where measurements. Yeah, so the default values that it can poll and understand is specifically in the memory. I mean, the heap memory is called the processes memory, and there is like a process use memory. So, if you use it, you're just going to have all that values supplied to you, and you can send it to whatever place that you collect your metrics and have your graphs. But also the cool thing about Polar that you can also provide any kind of functions, custom functions to it that it's going to include in its polling. And why it's important can be important for memory debugging. If you cannot debug some processes, some issues right away, but you have a suspect, like you suspect some processes, some modules, you can basically add your custom polling function through the poller that will collect the specific metrics of these, suspected processes. And then you can also put them on your dashboard and observe through days, weeks, or whatever until you're going to be sure that they do something wrong or not. Well, I guess that's it from my presentation. Yeah, I will take, I guess, a very short time. No, let's go with the Q&A first.
All right, so for anyone who has a question, you can just ask it on the chat. And I have a...
Alejandro, yeah, it's for a single node. Yeah, whatever we have seen is for the single node. Yeah, I mean, you can, even if you connect to one node, you can like, I think the Recon has utility tools that allow you to run certain commands on all the nodes in your cluster. So you can just, use it to, to collect the stuff about all of your nodes. Yeah. But generally, you're going to be working right at the node to which you connected to.
Okay, another question is, are any node slides links to share? Maybe.
Yeah, I can share my presentation. I uploaded slides here. I don't know. Can I share them from here?
Or maybe after the meetup, we can just send an email to everyone who
Yeah,
participated. If you can just
that's
let us know
yeah,
where
that's
it's, yeah.
yeah, it sounds good. Actually, better because I'm going to include the link to the Medium because I pretty much kind of reproduced, like written down my talk from the conference to the Medium post. As you know, today like a presentation might have been a little bit harder to understand if you haven't seen my my talk at Elixir Cons. That was like kind of where I tried to better explain how the memory works in Elixir. Yeah, but you can read the blog post and you won't lose anything if you haven't seen a talk at ElixirCon.
Okay, perfect. Okay, there is another question. Is it common practice to track detailed memory usage of Elixir applications on production with Prometheus and Grafana?
Yeah, I think people do that. Like detailed memory, in what sense? So, yeah, track a different allocations. So yeah, I think people do that. Like at least I have seen it at every place where I worked with Elixir. Mm-hmm.
Yeah, just to add a small thing, we also done it in some projects. So if you really need a better details on what's going on, then I think this is a good software you can apply to your project.
Yeah, it's really great. We also been using, I think AppSignal is called, but it's paid. That's too bad. But you install AppSignal library, AppSignal application to your, you know, um, to your project, and it's cool because it has a lot of like default metrics. It pulls, you don't need to do anything. You just start their application on the startup of your system. It provides you like a lot of stuff and draws it, creates automatic dashboards. Yeah, but too bad it's a paid software. Okay. Well, I guess that's all been all the questions, right?
Yeah, I think
So
so.
yeah, okay. Oh, wait, there's one more. Okay, I'm gonna answer the last one. What about libraries that allow a proactive approach to detect potential memory issues and run memory intensive operations on other nodes using something like Flame? Or invoking a remote process. The Flame, what kind of Flame? Like a Flame graphs?
I believe Francesco is referring to Flame library released
Hmm.
by Phoenix team
Oh, right.
about a couple of months ago, which allows you basically to run a certain function on when needed. You can spawn a node, let's say with Fly.io, run a
Mhm.
specific function that is heavy, that will not really have any impact on the main server processing. Things
Oh, right.
like, I don't know, PDF generation and stuff like this.
Yeah, well, so what I been so what I've been like focusing on preparing this talk are the issues that you cannot really predict. Yeah, like one of the things was just caching memory. That is, I think by most people would be considered super safe operation that would not like crush your nodes without of memory. Yeah, yeah, okay, you can run. It's always good to run like intensive operations somewhere else, but I guess a lot of things you just can never gonna predict until like it fails. Phoenix framework frame, yeah. Flame, okay.
Okay.
Or you can as well like do testing that, I don't know, can also detect sometimes like the existing memory issues. But in our case, it didn't, because like the database we used for testing was just much smaller. And when we're starting like pulling all the data from a real database, it was like a different story. Right, so can I use some minutes that left for like a self-advertisement?
Sure. Yeah.
Yeah. So I work with Elixir for already like 4 years or so, and I do these days a lot of contractual or like freelance work or consultant work. So yeah, if anyone interested, yeah, I'm open for any contracting or consultations. That's it.
All right. So I hope you find someone willing to work with you after this awesome presentation. Thank you very much for all of the debugging stuff you showed us today. I hope everyone will check out what you just showed, and yeah, if you can just send over the presentation, I'll share with everyone who participated today your presentation to basically explore those things in more details. Thank you once again, Anton. Thanks everyone who participated. I'll just drop a quick survey at the end that we always do.
Yeah, thanks for hosting me, guys, and have a good end of the day, I guess.
Yeah, have a good day. See you next time. Bye
Yeah,
bye.
see you.